Two users send requests to the same Node.js server at almost the exact same moment. One user checks their account summary. Another user checks the current dollar exchange rate. But JavaScript runs on a single thread. So how does Node.js process multiple requests without freezing? The first request enters the JavaScript call stack. Node.js starts executing the root handler. But this is an asynchronous operation. Instead of blocking the thread, Node.js delegates the operation to Node APIs. The JavaScript call stack immediately becomes free again. Now another request arrives. Because JavaScript is no longer waiting, Node.js immediately starts processing the second request. This asynchronous operation is also delegated to Node APIs. At this moment, both operations are waiting asynchronously outside the JavaScript call stack. Even though JavaScript uses a single thread, each request still maintains its own separate execution context. Variables like rec, res, user, and rate belong only to their specific request. When asynchronous operations are delegated, Node.js preserves the callback and its associated state. So when execution resumes later, the correct request continues with the correct data. The currency request finishes first. Its timer callback enters the macro task queue. That callback resolves the promise, which schedules the async continuation into the microtask queue. Once the call stack becomes available, the event loop resumes JavaScript execution. Node.js calculates the final amount and sends the response back to the user. Now the account request completes. But this next operation is very different. Unlike asynchronous operations, this heavy JavaScript calculation runs directly on the main thread. This CPU-intensive loop blocks the JavaScript call stack. While the thread is busy, the event loop cannot continue processing queues. Microtasks wait, macrotasks wait, new incoming requests also wait. This is one of the most important limitations of Node.js. Asynchronous I/O is non-blocking, but heavy JavaScript execution can still block the entire thread. Once the calculation finishes, Node.js sends the final response back to the user. Node.js handles massive numbers of connections efficiently, not by running JavaScript in parallel, but by avoiding unnecessary waiting. Asynchronous operations are delegated to Node APIs. Promise continuations are prioritized through the microtask queue. Other asynchronous callbacks are processed through the macrotask queue. And the event loop coordinates when execution can safely continue. Even though JavaScript runs on a single thread, Node.js still preserves completely separate execution contexts for every request. And that is the core idea behind how Node.js handles multiple requests.